Today we have a closer look at 4 of the most appealing mid-range printers of this year: Bambu Lab P2S, Creality K2, QIDI Q2 and last but not least Elegoo Centauri Carbon. Supported by thorough testing, we answer the question, which printer for whom? Spoiler, you get what you pay for. Today's video is sponsored by Bambu Lab. To be honest, I lost track for the recent printer releases this year. I mostly had my hands on bigger machines and tool changers. For many content creators, including me, there was this obvious Bambu Lab review marathon with the H2D, H2S, H2C and P2S. Testing to my standards is high effort, but it's also fun. And more importantly, it creates value for viewers and for brands. I want to help you make better decisions. And I want to give manufacturers honest feedback on what works, what doesn't, and what they can improve for future releases. And that's exactly what I wanted to do again. This time for 4 of the most important mid-range printers this year: the Creality K2, QIDI Q2, Elegoo Centauri Carbon and the Bambu Lab P2S. As mentioned in the beginning, this video is sponsored by Bambu Lab. They helped to make it possible. They paid for the printers in this comparison and for my time to run the tests and draw a fact-based conclusion. There was no creative input, all opinions are my own. The P2S is a very good printer, that's widely known, but it won't automatically be the overall winner. Any of these printers could be the right one for you, depending on your needs and use cases. And if you want to go deeper, all detailed test results, conditions and data are linked in a Google Sheet in the description. Let's start with a quick overview of the 4 printers before we unpack them. We're looking at quite a range of prices. At the time writing the script, several different discounts were active, so the printers ranged from less than $300 for the Elegoo Centauri Carbon up to around $550 for the Bambu Lab P2S. Creality K2 sits right in the middle at around $450. At $500, the QIDI Q2 is closer to the P2S in price, but it offers a slightly different value proposition. Its 270mm cubed build volume is a bit larger than the others, and high temperature capability is its main selling point. Up to 370 degrees Celsius on the nozzle and 120 degrees Celsius on the bed. On top of that, the Q2 includes an active chamber heater, which helps to heat the enclosure faster and keep temperatures stable. Something we'll take a closer look at later to see whether that results in meaningful advantages. For every printer, except the Centauri Carbon, there are multi-material systems available. I couldn't get my hands on the QIDI box in time, so for this video I'm only using Creality CFS and Bambu Lab's AMS2 Pro. The focus today is on the printers themselves, not on their multi-material boxes. The P2S combo, including the AMS2 Pro, is the most expansive complete package in this comparison. In the large spec sheet linked below, you'll also find Bambu Lab's P1S and Prusa's Core1 for reference, as these might also be interesting options. I excluded those printers from detailed testing because I had to draw a clear line for the scope of this comparison. This won't be a detailed unboxing video, but I want to give you at least a quick look at the differences and similarities I noticed, especially regarding packaging, setup and getting to the very first print. New users, in particular, rely heavily on this experience. I'm happy to report that all 4 printers arrived well packed, with no transport damage, and the first time setup is straightforward on every machine. Nothing unusual popped up and none of them annoyed me. What stood out? The QIDI Q2 includes a filament guide section at the end of its manual, going surprisingly deep into slicer parameters. The Centauri Carbon manual includes a wiring diagram for the mainboard, which beginners probably won't need, but enthusiasts might appreciate. Bambu Lab and Creality mainly focused their instructions on setting up their multi-material units, getting the first print started, and giving a quick overview of the hardware. Both manuals feel quite similar in scope and they get it right. Creality's K2 is the only printer that comes with a small but real spool of filament. The others include at least a short filament sample. All printers come with a basic set of tools, accessories and spares. No kit includes a spare nozzle though, and only the K2 comes with pliers which you need to cut filament. Setup wise, Q2 and Centauri Carbon are absolute no-brainers. Besides unwrapping, you basically attach the screen and the spool holders and you're done. On the P2S and K2 you also set up their multi-material units, the AMS2 Pro and the CFS. One difference worth noting, on the P2S the filament path setup is permanent, while on the K2 you need to switch PTFE tubes depending on whether you print from the external spool holder or from the CFS. First startup is very similar across all 4 printers. After removing transport fixations and setting language, Wi-Fi and time zone, each machine performs a sequence of self-checks and automatic calibrations. This is also your first real interaction with the touchscreens and their user interfaces. And here the differences become obvious. The P2S clearly has the most premium UI, the largest screen, highest pixel density, a very responsive touch surface, and Bambu Lab's newer Gen 2 layout, which feels polished. Creality K2 uses the smallest screen of the group, tiny bit less responsive, but still perfectly usable, and the UI strongly resembles Bambu Lab's first generation style. That's not a bad thing at all. On the Q2 and Centauri Carbon, resolution and pixel density are noticeably lower. Colors, layout, and overall polish don't match the others, but to be fair, everything works fine and I never was truly annoyed using them. What you'll probably use the screen for most often is loading and unloading filament. All printers guide you through the process smoothly. The P2S adds a nice convenience touch by automatically grabbing the filament as soon as the toolhead sensor detects it. A bigger difference lies in multi-material handling. Creality CFS, Bambu Lab's AMS units, and QIDI's upcoming box automate filament loading and use RFID tags to identify the filament material and color. Bambu Lab labels all their filaments with RFID. Creality and QIDI offer fewer RFID-ready options for now. For the first print, I loaded the included filament on each printer and used the pre-sliced Speedbenchy model. These first prints aren't intended to represent peak print quality. Manufacturers typically tune them for impressive speed and good enough detail. And in the case of the K2, the white filament doesn't help visually on camera. But don't worry, print quality will be tested in depth later. In total, I threw around 50 prints at these 4 machines, covering PLA, PETG, TPU, ABS, and multiple carbon fiber blends. Enough to expose both strengths and weaknesses. First, let's take a closer look at the printers, the tech, and the features. We're looking at 4 aesthetically nice-looking enclosed machines, each built from plastics, glass, steel, and aluminum, and each with its own small weak spots if you want to find some. All come with LEDs to illuminate the build space, but brightness differs significantly. I measure the lighting with a lux meter at the center of the bed at nozzle position, and the spread is quite drastic, especially between the P1S and the P2S. All printers use single nozzle toolheads on the CoreXY motion system, which has become the standard for modern enclosed printers. The P2S uses Bambu Lab's Gen 2 quick swap nozzle system, making nozzle changes fast and simple. QIDI Q2 and Creality K2 use Prusa-style nozzles with integrated heat breaks, which can be changed by screwing in and out. Elegoo sells complete replacement Hotends for the Centauri Carbon at a reasonable price. Swapping them involves 4 screws and plugging the heater and thermistor. I also checked the manufacturer's default flow rate limits in their slicers, as these reflect real-world melt performance better than any lab-based marketing claims. Bambu Lab also offers high-flow nozzles, which can speed up large prints or thick layers with higher melt throughput. Additionally, I measured nozzle heat-up times for all printers. Useful to know as you wait for that when you load or unload filament manually. When using multi-material systems like Bambu Lab's AMS, Creality CFS or QIDI's box, this matters less because loading is automated. All machines feature 2 part cooling systems, a toolhead fan for the nozzle and an auxiliary fan positioned either on the left, the right, or at the rear, as on the Centauri Carbon. The P2S stands out with a flap-controlled dual-mode fan. One position for cooling, one for supporting the heating of the chamber by recirculating the air. In cooling mode, it pulls in ambient air from outside, allowing PLA and flexibles to be printed at doors closed, keeping things quiet while preventing overheating of layers. QIDI and Elegoo recommend opening or removing the lid for low-temperature materials. Creality specifies an ambient temperature threshold for removing the lid. Practically, if you live in a warm region, PLA printing will therefore be louder. K2 and P2S are silent when idle. The Q2 and Centauri Carbon emit around 40 decibels when inactive. That's objectively not loud, subjectively potentially annoying depending on the person. All printers use double-sided spring steel plates with textured surfaces. The Centauri Carbon is the only one offering a smooth side as well. Bad heat-up times vary. P2S and Centauri Carbon heat quickly. Q2 is noticeably slower. A thermal camera check shows that none of the machines reach perfect temperature uniformity from center to edge. That's quite common and usually mostly irrelevant for real-world printing. To ensure comparable measurements, I printed a 0.2mm black ABS first layer before scanning with the thermal camera. We'll check first layer performance in more detail later. While the Q2 is slower at heating the bed, it heats the chamber quickly. That can help for strong, warp-resistant, high-temperature prints in, for example, ABS, Nylon, PPA-CF, PPS-CF and others. The other printers rely on passive chamber heating via the print bed. The P2S has an advantage here. Its flap-controlled fan in heating mode can recirculate warm air to speed up chamber heating and to keep warm air inside. It's not as fast as Q2's active heater, but noticeably faster than K2 or Centauri Carbon, which struggle to reach 30 degrees Celsius in a reasonable time. Measurement method, bed at home position, chamber heater and or print bed maxed, and internal chamber temperature is read from the built-in sensor. P2S was operated in heating mode with fan at 100%. Now the interesting part. While this video is sponsored by Bambu Lab, P2S is not perfect here. Or better, wasn't. Earlier firmware versions lacked a filtered exhaust path for cold printing, namely PLA, PETG or flexible materials when using the cooling mode. A recent update added optional post-print air purification using recirculated filtered airflow, and an external exhaust kit will be available at some point. Users can also print mods from MakerWorld like Through the Frames Vento system for a left-side filtered exhaust. By default, K2, CC and P2S all use activated charcoal exhaust filtering. Q2 includes a complete multi-stage filter system for coarse and fine particles as well as VOC, making it the strongest in filtration. In terms of connectivity, Q2 is the most complete as well. Besides USB and Wi-Fi, it's the only one featuring Ethernet for those preferring wired reliability. Wi-Fi was stable though on all printers during my testing. Sending prints from slicers worked flawlessly. Speaking of slicers, each manufacturer uses a branded slicer. QIDI slicer, Creality Print, Elegoo slicer and Bambu Studio. But under the hood, they all derive from slicer or Prusa slicer roots. Bambu Studio is also based on these roots and Orca slicer is based on Bambu Studio. In the end, they all feel familiar but vary in detail. Profile availability and material libraries can also differ noticeably. We'll get there later. All printers, except P2S, run on some form of open source Clipper firmware, but access levels differ. QIDI gives you near full access to Fluid and the file system, enabling for deeper customization possibilities. Creality K2 offers full Fluid access via browser and the file system is accessible. Centauri Carbon provides heavily limited access. Too limited in my opinion, as that can complicate troubleshooting. Bambu Lab uses closed-source firmware with limited access. Their machines are optimized to work best within their ecosystem, meaning Bambu Studio plus the Bambu Handy app and using their cloud connectivity. Not everyone likes that, we'll talk about that in the conclusion. There is a LAN-only mode, but with restrictions. I linked an overview below for reference. All manufacturers offer smartphone apps, though Centauri Carbon is not yet supported by the Matrix app. Still, it has a built-in camera like the others. All cameras support up to 30 FPS, resolutions between 720p and 1080p. Image quality varies mainly by lighting, but all are fully usable for print monitoring. Before diving into printing performance, a quick disclaimer. I usually don't tweak slicer settings for these tests. Intentionally. My goal isn't to show the nicest possible prints, I show what users get out of the box with default slicer settings. I expect manufacturers to tune their own material profiles properly and to provide good generic profiles for third-party filaments. Second disclaimer, I don't do multicolor test prints on these machines anymore. With one nozzle and material multiplexing, waste and print time explode. AMS and CFS are great for convenience and quick filament access, but not ideal for multicolor, maybe occasionally. All filaments, PLA included, were dried and kept dry during printing. There is one exception later, intentionally. Across all tests I printed over 50 parts to get a solid understanding of strengths and weaknesses. We'll focus on the most telling results rather than walk through every single print. Testing spans PLA, PETG, TPU, ABS, Nylon, PA-CF, PPA-CF and PPS-CF. Spoiler again, there is no overall best. All machines have weaknesses, including the P2S. Important note, all PLA tests use each manufacturer's own PLA filament and their tuned filament profiles. This represents what the manufacturers intend to deliver in terms of print quality, if they tested their machines, profiles and materials accordingly. First, I wanted to know how flat the beds are and how well probing and mashing works. I printed a full first layer from PLA across the entire bed. The best way to judge first layer consistency. Plates were cleaned with IPA beforehand. As seen in my P2S review and in many others, P2S performs extremely well here, at least for PLA. ABS behaves a bit differently later. Creality K2 also performs well except for one tiny spot there. Out of the box, Q2 and Centauri Carbon struggled. The set offset was too high on both. On Q2 this is easy to fix permanently through fluid and clipper. On Centauri Carbon you can only adjust the offset during a print, which is inconvenient, and as we'll see later, doesn't fully solve issues across all materials. The 3D benching results were all good, nothing dramatic. Centauri Carbon and Q2 show some ringing and rather fine artifacts, but nothing alarming. The KSR test reveals more. Creality K2 shows the most stringing. Retraction tuning and maybe flow calibration could fix this. The 0.2mm tolerance print was stuck. On all other printers it came out easily. Q2 performs well overall, but some sagging on overhangs and bridges. Centauri Carbon shows some ghosting, stringing and ringing. Also those fine artifacts. P2S performs well, like in my review back then. Only a slightly sagged bridge and some imperfect overhangs visible from below. The pins are clean and basically free from stringing. I repeated the KSR test with Sunlow PLA Plus I had laying around for ages to check behavior with undried generic PLA. Q2 prints almost the same as with dried filament, just slightly more stringing. K2 shows significantly more stringing and a bit of flawed layer stacking. Centauri Carbon is similar. Strong stringing, sagged bridges. On both, tuning flow rate, retraction and pressure advance helps noticeably. P2S shows a bit more stringing and sagging compared to dried Bambu PLA Basic, but overall remains solid. Possibly automated flow calibration on Bambu Lab machines helps for quality consistency when using undried third-party filament. Next, Prusa's Scandic plate with crazy overhangs. This one exposes cooling system strength and slicer tuning for overhangs. To be honest, these results made me nervous in a sponsored video like this, but it is what it is. Only P2S and P1S handled this print well. P2S showed one sagged perimeter but otherwise clean results, no curling, no overheating. On the other printers you can actually see the auxiliary fan locations. Areas outside the airflow show overheated or curled overhangs. Centauri Carbon is hit hardest, K2 is borderline, Q2 is okay but unfortunately not perfect. Does this mean they're bad printers? No. With tuned slicer profiles you could get good results. Bambu Lab and Prusa might have tuned their profiles for these test scenarios. Moving on to PETG with the Voronoi here. All printers handle this one well. Differences exist, but none are actually meaningful. PETG retract performance is good through the bank. The prototype part printed from shiny black PETG shows something more interesting. Coarse layer performance and vertical fine artifacts. VFA in short. All printers printed good parts, but these VFAs were visible on all of them. Different patterns depending on belt pitch, motor and driver behavior and system resonances. Q2 uses 1.5mm pitch belts, which creates a narrower pattern. P2S, K2 and CC use 2mm belts with correspondingly wider spacing for the VFA. Centauri Carbon shows strong fine pattern artifacts, likely driver or motor related. Bambu Lab's P2S has struggled with VFA in the past. In my October review it was very visible. A recent firmware update improved this considerably, as you can see, and Bambu Lab is still working on improving it here. Next, TPU. I printed this Voronoi cat. That one is brutal on retractions as well. All machines completed the print without clogging, not a given. On a side note, all went smoothly and reliably. No problems so far, except for initial set offset topics on Q2 and Centauri Carbon. Though Centauri Carbon performed well on TPU. Stringing probably can be avoided completely with this model printed from flexibles. P2S and Q2 perform similarly. K2 produces more stringing. Important note here, Creality does not provide a generic TPU profile in their slicer. The only TPU profile available is for their high flow TPU, which is not perfectly suitable for this test on TPU95A. With a proper generic profile, K2 would likely improve significantly here. Now let's move on to high temperature materials: ABS, Nylon, PA-CF, PPA-CF and PPS-CF. We begin with another full bed first layer test, this time using ABS. At these temperatures, the behavior of the print bed changes noticeably. The entire bed needs time to soak heat evenly before any probing or printing. Bambu Lab and Creality include dedicated high temperature probing routines for this, while Q2 and Centauri Carbon require manually preheating the bed for around 10 to 15 minutes beforehand. On the P2S, the ABS first layer wasn't absolutely perfect, few thin spots remain, but overall it performed well. The K2 produced a fully closed first layer, though slightly more uneven than P2S. With small adjustments it could be made nearly perfect. The Q2 bonded so strongly to the bed that the ABS sheet actually cracked during removal. The fragments, however, clearly show that the first layer printed correctly, and the subsequent higher temperature prints confirmed that as well. Centauri Carbon behaved unexpectedly. Even after proper preheating, the firmware forces probing at roughly 60 degrees Celsius instead of the intended 90 degrees Celsius. Adding a custom G-code fixes the probing temperature, but even then, the front area of the plate remained inconsistent. No clue here why, I had to stop troubleshooting at some point. For K2 and Q2 we can look at the bed meshes. The K2 shows around 0.2 mm of height variation across the surface. Not ideal, but manageable as long as the mesh compensates properly. Q2 shows roughly double the variation, which can still be corrected, though mechanically flatter beds are always preferable. I was not able to visualize the bed mesh on Q2. For all subsequent high temperature prints, I used glue stick on every bed to ensure equal conditions. The benchmark part for all of these tests is the Warren Stealth Burner front, a complex, bridge-heavy and warp-prone model that helps reveal weaknesses quickly. On ABS, the P2S again showed vertical fine artifacts and some ringing on the edges, and the first layer was slightly off, possibly due to too much glue on some spots. Otherwise, the part came out flat and free of warping. The Q2 performed slightly better regarding VFAs, produced clean outer walls and showed some little warping at the top and bottom of the part. Centauri Carbon showed several defects on the outer walls, a noticeably squished first layer due to drifting set offset and mild warping on both ends. The K2's first layer wasn't perfect either, maybe too much glue stick as well, but its walls looked clean and warping was minimal. Moving on to Nylon, here plain PA6, which can be a nightmare. P2S handled this demanding material well, showing minor warping and a bit of stringing. Q2 delivered a cleaner result with sharper edges and less stringing overall. On a side note, I used QIDI's Ultra PA profile with adjusted temperatures because no proper generic PA profile exists here. K2 and Centauri Carbon both technically offer generic PA profiles, but they're not tuned correctly. Cooling is too aggressive on the CC, and temperatures are off on the K2. Pure nylon doesn't seem to be a priority for some manufacturers anymore. After adjusting the filament profiles, K2 and Centauri Carbon delivered satisfying results, though both show more and less warping. For carbon fiber reinforced materials like PA-CF and PPA-CF, all printers basically performed well. The added fibers reduce warping drastically, so bad adhesion is less of an issue. On the K2 I had to create my own profiles because none were provided. Centauri Carbon struggled a bit with PPA-CF. Layer stacking was inconsistent and the set offset drifted again, making first layers at high temperatures somehow unreliable. P2S, Q2 and K2 all produced solid, usable carbon fiber parts. Finally, PPS-CF. This material pushes temperature requirements to the limit, and among the tested printers, only the Q2 can reach those temperatures safely. Using the official generic profile, the Q2 printed PPS-CF without any issues. The first layer was clean, warping was naturally non-existent, and surface quality was excellent. As I said in the beginning, there won't and can't be a single overall winner in this video. And interestingly, there isn't a true loser either. In one sentence, the outcome of this video is, you actually get what you pay for. The Elegoo Centauri Carbon is clearly the cheapest but also the weakest overall, but its low price still makes it appealing for certain users. If you're on a tight budget, and you don't mind tinkering, adjusting and occasionally troubleshooting, the CC can be a workable option. But keep in mind, firmware access on the heavily modified Clipper build is extremely limited, so your ability to tune the machine is restricted unless you're willing to replace electronics at some point. The CC works, but it is not a perfectly convenient, beginner-friendly, fire-and-forget printer across its full advertised temperature range. And since it's unclear when, or even if, Elegoo will release a proper multi-material system, the ecosystem around it remains uncertain. Creality's K2 and QIDI's Q2 were the biggest surprises for me. Both companies struggled in previous comparisons I made. The QIDI X-Max 3 and Creality K1 Max were clearly rushed to the market when I tested them, and that showed. Neither delivered a smooth plug-and-play experience back then. But the new QIDI Q2 as of today, the touchscreen and UI aren't top-notch, and the build quality isn't full premium. Generic filament profiles are also limited, but other than that, it was reliable, produced good print quality, and thanks to nearly full access to Clipper, can be tuned and customized extensively if you want. With its high temperature capabilities and active chamber heating, it's even ready for PPS-CF and other demanding engineering materials. Its price is on the higher side of this comparison, and QIDI clearly knows the strengths they are offering. Still, if you want a polished multi-material experience, the QIDI box might not meet expectations based on what I've heard. So do your research before buying. There are some trustworthy reviews out there. As for Creality K2, and this might sound surprising in a Bambu Lab sponsored video, but at its current discounted price, K2 offers genuinely strong value. It was reliable, print quality across all tested materials was okay, and the only issue I ran into was self-induced. I cut power during filament loading and caused a script loop. Once I downgraded and upgraded firmware again, it was fixed. K2 series, software-wise, has improved significantly since I tested the K2+. Full Clipper access is available, and Creality's CFS works well. My complaints are mainly that filament profiles are limited and that the broader Creality ecosystem isn't nearly as unified or as complete as Bambu Lab's. Spare parts, at least from my experience with the extruder motor, can take weeks to arrive from China. But the bigger picture is, the gap between Bambu Lab and its competitors is getting smaller, and that's good for all of us. Which brings us to Bambu Lab's P2S. You probably know from other reviews what sets Bambu Lab apart, so let me start with the reasons why you might not want a Bambu Lab printer. Don't buy one if you don't want to use their cloud services, if you need full firmware access, or if you want to use only third-party slicers. Some people simply don't feel comfortable with that level of ecosystem lock-in, and that's totally fine. But if you want a reliable, convenient and polished 3D printing workflow that feels more like using a tool than maintaining a machine, the P2S or maybe the P1S fits exactly that. Bambu Studio and Bambu Handy are well integrated, there's a wide set of high quality filament profiles, and the cloud offers advantages such as remote monitoring outside your network and synchronized print profiles across devices. LAN-only mode exists as an option, even though it comes with limitations. Spare parts are affordable and usually available within days. Accessories are plentiful and reasonably priced, and RFID filaments are offered in a wide range. MakerWorld as a market for print projects is also growing quickly and is well integrated in the ecosystem of Bambu Lab's filaments and parts for projects. The P2S is the most expensive printer in this comparison, but also the most technically advanced. It is what it is. With the new Gen 2 features it brings to the table, Bambu Lab still stays ahead from a pure technology and convenience perspective. Yes, the competition is catching up. And I repeat, this is great, this is exciting to see, but P2S remains the most complete package overall in the mid-range class. If you want all specs, test results and price indications at a glance, check out the big spreadsheet I created. It might help with your decision making as well. Thanks for watching, servus and bye bye. We'll meet next year having reviews, projects and probably some absurd printers again. Thank you, Shulo!